Today we're going to look at what happens to hydrocarbons when we start messing around with them by adding double or triple bonds or adding oxygen atoms to the mix. So you can see here we have an almost infinite variety of molecules. When we make these changes, we call these small groups of atoms functional groups. By understanding these functional groups, we can predict the chemistry that will happen, as you can see with the formation of a peptide bond or the formation of a fat. As we focus on the functional groups, we will call the rest of the molecule R. So as you can see, all four of these molecules can be represented as ROH. As we know, alkanes are saturated hydrocarbons. Unfortunately, saturated hydrocarbons are pretty boring. That's not to say they aren't important. Methane, which is natural gas, propane, butane, and octane are very important sources of energy through combustion. So let's take a look at our first type of molecule, cycloalkanes. They are just like the name says. They're alkanes, but they're in a closed ring. They're still saturated, but their general formula is CnH2n. There are two less hydrogen atoms in a cycloalkane than there would be for an alkane. Take a look at their formulas and names. The first one, if we count, has 5 carbon atoms. In this representation, the intersection is the carbon atom. We also have 10 hydrogen atoms. So the formula is C5H10 and the name is cyclopentane. If you recall, straight chain pentane is C5H12. Pause for a moment and try to name the next two. Hopefully you came up with cycloheptane, 7 carbon atoms, and cyclodecane, 10 carbon atoms. The hardest thing for me when naming these is keeping track of where I started counting. Alkenes are similar to alkanes, but they have one or more double bonds between carbons. Remember, there are never double bonds between hydrogen and anything. Every double bond removes 2 H atoms from the formula. When there are carbon-carbon double bonds or triple bonds, we call these molecules unsaturated. You might have heard saturated and unsaturated when talking about fats. Well, this is how they got those names. Unsaturated fats, which are healthier for you, have one or more double bonds, while saturated fats have all single bonds between carbon atoms. Naming alkenes is very similar to alkanes. We start with the prefix, but then use the ending ene. C2H4 is ethene. Similarly, C3H6 is propene. But look what happens when we get to 4 carbons. There are 2 different choices for where to put the double bond, and the names reflect that. We use a number before the name, so the double bond between carbons 1 and 2 is 1 dash, and between carbons 2 and 3 is 2 dash. We can differentiate between these two molecules because their names are 1-butene and 2-butene. So now we have 2 molecules with the same molecular formula and different names and structures. We have 2 isomers. What do you think the name of the last one is? We have 6 carbon atoms, and the double bond is between the second and third carbon, so it is 2-hexene. We can have a triple bond instead of a double bond. This changes the ending of the name to YNE, pronounced ine. It reduces the number of hydrogen atoms again, so there are 4 less than an alkane. When we name the first alkyne, it has the name ethyne. Try to use the patterns to determine the names of the rest of the molecules on this page. 3 carbon atoms gives us propyne. 4 carbon atoms is butene, but we have 2 possible structures. Just like alkenes, we indicate the position of the double bond with a number before the name. And just like alkenes, these 2 alkynes are isomers. 6 carbon atoms with a triple bond between the second and third carbon is 2-hexyne. Try drawing structures for these 3 molecules. Cyclopropane has 3 carbon atoms in a ring. Because each carbon atom gets exactly 4 bonds, there are 2 hydrogen atoms on each carbon. You didn't need to draw the wedges and dashes, but they emphasize the shape of the structure. 3-hexene has 6 carbon atoms. Because of the 3, we know the triple bond is between the third and fourth carbon atoms. Then we make sure there are exactly enough hydrogen atoms to make sure that there are 4 bonds for every carbon. 2-pentyne works the same way. The triple bond is between the second and third carbon atoms, and every carbon has exactly 4 bonds. There is one more carbon-based functional group to know about, and it shows up everywhere. It is in vitamins, proteins, hormones, dyes, fragrances, solvents, and all sorts of molecules. It is called a benzene ring. Molecules that contain a benzene ring are called aromatic. Take a look at the benzene ring. It is 6 carbon atoms and 6 hydrogen atoms with what appears to be alternating single and double bonds. That isn't really true, but that is an AP chemistry topic. It is so common the chemists have shorthand shown here. It is very hard to break up a benzene ring, but it's very easy to substitute one or more of the hydrogen atoms, as seen in this chart. Well, these are some of the interesting ways that hydrocarbons can be modified. In the next video, you will see what happens when we add 1 or 2 oxygen atoms to the molecule. As always, if you have any questions, let me know.